Okay, hello, welcome to another one of my video log recording sessions where I talk about genetic algorithms. So, the time and date time is 2025 April 21st. The time is 02:17 in the morning, rather past midnight. And this video is this very video is going to be just me ranting and mumbling on about what I have been doing. So it's a bit of an update and the challenges that I have to overcome, the issues that I have to deal with, and etc. etc. So, what am I doing? Well, what am I doing? And the answer to this question is that when I came up with the better evolution scheme, which included some small a small change to the selector function, but major changes in how each iteration of evolution is carried out, and as a result, the order in which these iterations, or the order in which one generation is performed, or one generation rolls out, is that the world. What am I doing? Why am I not typing? Hello? I have no idea what I did. So the world, full of population of entities, when it enters one generation, whether it be the first generation or the second last or the last generation, this world of population of entities is ranked, and then the world is a list, and it is ranked, and as a result, an entities dictionary is created and formed, and then I sort this dictionary by key, where the key is the sum util val. Summer. Oh, I missed summer. No, not the Rick and Morty summer, but the season summer. So anyway, I told you I was going to be ranting and mumbling. So where sort by key, where key is some utility values of entities, and once this, from high to low, or rather highest to lowest, highest to lowest, depending, within the context of the problem space that is, at large at this point. For now, it's always fixed, but then I always find time to stress this. Problems can change. Or the problem space or the conditions can change, or will change in the future. And I think that I'll call dynamic conditions, or dynamic problem space, or something like that. Something like this. So the dictionary is sorted from highest to lowest, and then the dictionary is then again flattened into a list called a world again. So the difference between this list and this list is that this one is not ordered, or rather sorted. This one is, and I'll come back to that in a second. and then somewhere there we do the metrics and then store them. And what else do? We procreate. Why is it in red? Because I just used red. We procreate and then select newborns, add newborns at the front. Oh, where's my mouse? There we go. The front of world. So it becomes newborns, something like newborns selected, newborns plus world. Oh my god. So really? That's so bad. Let me just fix that. It becomes selected, newborns plus world. Something like this. And then every entity in the world has to mutate, goes through mutation. Yeah, and then every entity is subject to which one's first? I always forget. Selector and then world. So subject to the selector function. By the way, this select and this select is different. They're not the same. Maybe I should just say chosen. Or not, whatever. And then select a function, and then I limit the population. Seriously, oh my god. Limit the population. So that is end of generation. End of a generation, and then start of a generation. Everything just gets carried on like this. So that's the better evolution scheme. So now that I have this, I wanted to find out the peak plateau plots for all these distributions, all 8 of them. What was it? Exponent or expovariate, whatever. Von Mises, Pareto, Fable, just something left skewed. So these 8. For this is for util. That's just weird. I don't know why. This is for constraints. So, and I already have normal, log normal, uniform. I already have these. I know sample separately, but still I already have these. So what I wanted to do was again get all the products of these. So it would be normal, log normal, uniform, normal exponent, exponential, normal von Mises. So that's 8 of them, and that's 8 of them. And we do the math, and then it's 64 of them. But here comes the problem. Last time when I did it on Colab, on Google Colab Pro Plus, since I'm not using any GPU, not ever for this project, I'm only using CPU and maybe RAM as well. So using Google Colab Pro Plus, the only thing this helped me was that I was able to keep the Jupyter notebooks running. So that was the only huge plus. However, it cost me something like 110 USD. So I swore to myself never again to do that. You know, because this is still my money. So what? So what I did was I made the notebook that would do this into a set of Python scripts .py, and then I hosted these. I hosted my Python scripts into AWS EC2 instances, and well, I'll just show you now. Here we go. I have 12 of these, but well, to be blunt and brief or precise or whatever, concise, they are painfully slow right now because I'm not using I'm using the free tier. So, and the reason I have 12 is that when I had Google Colab, each notebook from notebook 0, notebook 1, notebook 2, and to notebook 3 had all the what they did was they did all the calculations for 16 distribution products each. They had they would do all the calculations or evolutions for 10 items, 40 items, and 100 items. So I had 4. However, well, people who are quick would just instantly know why now I have 12. However, in this under these circumstances, when I'm using EC2s, I made one instance for 16 distribution products for 10 items, another 16 distribution but for 10 items, another 16, so that's 4. And then the same for 40 items, and then the same for 100 items. And they're all running simultaneously. So that's why I have 12 instances. And since they're all running simultaneously, this will finish last, obviously. Because so far I think, well, not I think, I've seen the timestamps, and usually for 10 items it takes, 3 hours? Which is really painful. Holy. It's supposed to take 10 minutes, but it takes 3 hours. Oh my god. So that's 48 hours for this. 48 hours. This one takes about, let me see. Let me see. It takes about 3, 4.5 plus 512. Oh my god. Wow. 4.5 plus 512. Well, 4 minutes and 30, 4 seconds, 4 hours and 30 minutes, and then 5:12 minutes. So that's 9 hours and 40 something minutes. Let's just say 9:50. So 9 hours and 50 minutes. 9 hours and 50 minutes. So let's just say it's 10 hours. So this will take 160 hours. And by the way, this one takes approximately slightly less than 280 hours. Well, the good news is that this will finish last, so within this time, all these two batches will finish. So I only have like 250 hours to go, because around 24 hours have passed. 250 hours. That's 10 days plus 10 hours. So that's what these EC2 instances are doing right now. And they are horribly slow. Let me just show you. Let me show you this one. This is from the second petition. Oh my god. And I can't, something went wrong and I can't even what did I do? Yeah, okay. And something went wrong and I can't even access my EC2 instance through this EC2 dashboard. So I'm using git bash and SSH access. So here I am. Yeah, what am I doing? I'm showing the process. Yeah, so this happened. 9 out of 16 are done. And they're all being stored, well, locally, not locally, but locally for the EC2 instance. And then I have to push the JSON files to GitHub. And then on GitHub, because I have 12 instances, I didn't want to like deal with merging all of them. What I did is well, create 12 branches. Yep. So in May I'll have this, and remember again, this is all for this graph, these plots. I'm doing it all for these, which is really crazy. Yeah. But if I think about this, no, I mean, if I think about this whole situation, Python is slow. Python is slow. Is slow. Good God, I need a pen. My writing is slow too. It's slow. It's just so painfully slow. On my laptop, it's, well, quick enough. On my desktop, it's a bit slower. On Google Colab Pro Plus, it's even slower if I don't use the GPU. And on AWS free tier EC2 instances, it is just horribly slow. Which begs the question, should I keep using Python? Are there other languages, such as maybe C or Java or C++? But there's a huge downside here, is that I don't know these languages. Another option, which, now that I've said, now that I've said that I don't know these languages, so it's not likely that I'll be using these in the foreseeable future. Another option is keep using Python, but find a way to utilize GPU. Yeah, and if I wanted to use GPU, I'd probably have to use PyTorch, or what was that other one? Python genetic algorithm, PyGAD, GPU. Yeah, so there are ways of doing this by utilizing GPU. But well, and if I wanted to use GPU, it would probably be a lot wiser to start using NumPy instead of just Python lists. Would that be faster? Maybe. These options will definitely make it faster. But here's the problem. This is my problem. It's a problem because I see it as a problem. And the problem is that I wanted to make this project not dependent, or well, as independent as possible. I think that's the right way of saying it. As independent as possible. Because if for somehow if I do create a successful population of entities, successfully just manage to make a world, I don't want the entities to be confined. Being confined is not what I want. Of course, then then using Python is actually a bad idea. So this will have to happen in the future, but not right now, and not by me. But this will definitely have to happen. But in the meantime, trying to use Python, but as few libraries and packages and modules as possible. Because if I do that, then there'll be a lot more imports, a lot of more dependencies. How do you spell that? So that's a no-no. I mean, this is what I think is the least of imports. Import random, import copy, import ether tools, and etc. And if I ever start that thing, I'd also have to deal with the inputs and outputs, the bits and bytes, etc., etc. So there are still more imports to come. There are still more modules to be imported. I just don't want to be importing NumPy, Pandas, PyTorch, or TensorFlow. Not just yet. I don't think this is important. I don't think I should be relying on these. I don't want to rely on these ever, but I'll keep assessing the situation, trying to weigh the pros and cons. But this will have to happen. C, Java, C++, etc, etc, etc. But you know, I don't want things to be language specific. That's why I'm doing this. I mean, that's why I'm doing this way. Should be the right way to say it. And by doing this, I have spiked up my AWS bill. I usually pay $31, and now it's up to $35.63, so about by $44. I need 10 more days of this. So, well, now it's been about one whole day. So, 10 more of these, about 20 more, 24 more. So this is going to go up to $60. Holy shit. But I've had the membership, and I was paying $31 per month for, you know, I'm ashamed to say, but for no good reason. It's just another $30+ additional. So I can say that this whole thing, doing it on AWS, is only going to cost me $30. At most $40. Which is still a lot cheaper than $110. But it would be nice if I could do it faster and more reliable, in a more reliable way. And then what's next? Well, what is next? Well, 2 days ago, 2 or 3 days ago, rather, I made another notebook with all the preset items. You know, the laptop, the vape juice, the vape, the pen, the papers, all that, and 50 items. Was it 50 items? Let me check. Yep, 50 items. 50 items, and then 50 util vals, and 50 constraint vals. And then I have all that, you know, procreate functions. I forgot all the names. 10 of them. And I ran all these evolutions 5 times. 5 times each. 5 iterations per procreate function. And then what did I do? I compared and all the summed plateau plots for the heads. Well, what is this? Heads. Top 10%. And tails. Really? Yeah, that's what I did. And they would, you know, they would be different. I mean, that's what I did. But in the end, this notebook kind of still proved that, number one, the new evolution scheme also kind of affected them, you know, because now there were, you know, almost no dips. Number two, even with the new evolution scheme, the procreate functions all had you know, different effects, different metrics. You know, they behaved differently. They created different worlds, which were shown by the plots, and the plateaus were different. The peaks were different. Although there were no dips, or there were almost no dips, they still produced different results. And one smaller thing is that oligopoly still seems to be the best procreate function. I don't want to say best. It's the most decent one for now, because well, because it actually produces a robust kind of like a robust distribution of oh, that's a good bell curve of entities. Well, kind of slightly skewed to the right, but still. Oh, another nice one. Nice. And random is doing everything by random is horrible, but I still think it can be utilized in some cases. Yeah, I shouldn't talk about this right now. In another video I should do this. But yeah, that's what happened. I did the 10 procreate functions. So I'll talk about that in one of my next videos. Wish me luck for the next 10 days. Let me just see if it's still at, so I was still doing the 10th distribution product that is assigned. Okay, fine. Yeah, thanks for watching. Bye bye.